So, so just for a moment, consider, right? We've managed as a human species to create a system where you can connect over a network. You boot up your computer and you connect to any other arbitrary computer on the planet. And you, not only that, you download executable code onto your machine, right? And then you run it. And not only do you run it without any fear that it will mess up your system. It's completely sandboxed. It has its own little environment that will never mess up your files. You can run anything from document readers to financial trading systems to hardware-accelerated 3D games through this system we've created. And it'll work no matter what your CPU architecture is or what form factor your device uses. And so I'm referring, of course, to the web, right? And I'd say that this feat, this marvel of human engineering, is up there with few others in human history. And in fact, the one big accomplishment that I would compare this to the most is the moon landing, right? Because this picture represents the culmination of many, many hours of work as a species. And I claim that the last one does as well. Consider what it takes to build the web platform that we have today. The amount of cooperation between disparate parties, the bedrock that we had to lay down first, and the giants whose shoulders we stood on just to get to this point. Consider the people whose entire job it is to build this platform that we use, so that on top of that we can achieve our goals and build our products. We call these people standards bodies. And yet, some people don't seem to appreciate that accomplishment, right? And what's worse, on the stage of LXJS last year, we had somebody telling them to fuck themselves. Their antagonism seems to be based on some serious misunderstandings of what exactly standards bodies are and what it is that they do. So I spent the last year diving into this world, this moon landing-esque world of building the web platform, and I'm here to report back with what I've learned. So I think the best way to get at the core of what the web platform is, we have to go back to kind of the genesis of the modern web application era, and how standards bodies really got started in this era. So the key year is 2004. So if you could think back to 2004, what you were doing all those years ago, and what the web was like, there was a new technology that was all the rage. Does anybody remember what it was? Yeah, it was XML. So from 1999, when HTML4 was finalized, all the way through 2004, the W3C had been pushing XML everywhere, right? We were going to be saved from ourselves by XHTML. We were going to get SVG and Smile, if you remember what that is, and Xforms and Xlink and MathML and XML events. That was the future in 2004. But there was some concern from some parties that this wasn't actually going to solve any of the problems that we wanted to solve. One guy, Ian Hickson, of Opera Software, said in 1994 or in 2004 that the W3C has so far failed to address the need for web applications, which is what was starting to be built. His examples were kind of fun, looking at them from a modern era, things like Bugzilla or this 2D side-scroller game. But obviously this is the direction the web was moving. It's the direction it has moved. And this all came to a head at this workshop in mid-2004 in Adobe offices in San Jose, the W3C workshop on web applications and compound documents. And Mozilla and Opera jointly proposed a set of design principles, and they tried to get a vote on whether the W3C should extend HTML and the DOM to support web applications. This vote was defeated, 8 yes, 14 no. So realizing that the W3C had lost its way, Mozilla, Opera, and Apple together formed the Web Hypertext Application Technology Working Group, or WHATWG. The WHATWG is a pretty amazing standards body because they proved, as somebody told me last night, that you can put together a standards body for $80 a year in mailing list costs. It's open to anyone. It's largely composed of implementers and other people just who are willing to spend their time on the mailing lists making the web a better place for web applications. This is where the majority of work on web standards is done today. It's done in the open, on mailing lists, on IRC, on things you can publicly access, and increasingly it's moving towards GitHub. The people who write standards are the same as the ones who implement them, and the process is open to anyone. So this is the major misconception that people seem to have, is that they're getting standards from some research institute. And that might have been true back before 2004. People still haven't caught up. The talk last year that I was referencing made it clear that the speaker didn't really understand what standards bodies were, because his example of an anti-standards body was a shared Google document where all the implementers would modify it, and that was the source map spec. Well, that's exactly what a standards body is a shared document where the implementers collaborate on how we're going to create this thing. And just speaking to who is in the standards bodies, from Hannah's talk earlier, the decisions are made by the people who show up, and the code is written by people who write code. Well, it's the same thing. Specs are written by the people who show up and the people who write specs. The web platform is driven in the same way as open source. So more generally, taking a step back, how do standards work, right? Like, what is the idea? Well, the idea is that the web community, or perhaps some implementers on behalf of the web community, they identify a problem, something wrong with the web platform, a missing piece of functionality, or something that's harder than it should be, or something that's not interoperable across browsers, or something like that. And then, this is the key step, they convince implementers that that problem is real, and that it needs to be solved, and that it can be solved. Because if the implementers don't care, nothing's going to get done. Right? If you just write a bunch of spec text, expecting people to implement it, but never really checking with the important people who are going to be writing the C++ behind it, they'll ignore you, and we'll have 2004 all over again. So once that's done, once the problem is identified, then they try and come up with a solution to the problem, debating aspects of the solution and nailing it down in spec language. And that's the part that feels like it can drag on for a bit. Because solutions are hard. This is also known as the why haven't we spec'd the damn picture element already problem. Well, the thing is, this process is there for a reason, right? You need to make sure that the problem that was brought up is actually solved, and that all the browser vendors are willing to solve it in that particular way. The work that needs to be done is in proportion to how hard it is to get an interoperable implementation. Back in the HTML4 days, that spec was not at all what browsers were actually doing. Browsers had to make up their own rules for example, error recovery. Nailing down in the level of detail required by a modern spec is quite a lot of work. And this goes back to, I think, our moon landing parallel. It's not easy to make something that can be implemented across the entire platform in this amazing collaborative effort. Getting consensus from everyone means getting a lot of people to agree, but a lot of the concerns raised along the way are useful input into the process. What's interesting is if you're building things for just one platform, say Node, right? You don't need interoperability. You don't need consensus. You can just make dictatorial decisions, commit them to master, and we'll deal with them. But if you want something to work on the entire web, on this entire cross-browser ecosystem where you can download code onto your computer from anyone else, then you need to get the buy-in from the people who make the web work. And that's why we have standards bodies. One innovation in the standards process that I think I want to highlight is the idea of a living standard. And the easiest way to think about this is to first consider the model that came before, right? Because we had specs, snapshotted specs, HTML 1, 2, 3, 4, 5. It's not like browsers actually implemented 5 separate versions of HTML. Instead, they just implemented HTML. And the latest draft is what they implemented, but they also might have added some extensions so their users get things done, or modifications for compatibility. The idea is to bring this process, what browsers actually do, what runtimes actually do, to the standards bodies themselves, to the standards, the specifications themselves. They should be updated continually as feedback comes in, as new features are agreed upon, or as bugs in old features are discovered. There's no point in producing these outdated spec snapshots that are brought down from standards mountain to remain forever locked in obsolescence. That's not how it should work. And this idea has been largely a success, starting with the HTML living standard. You may have heard that the term HTML5 is abolished, and this is basically true. The WUTWG has abandoned the versioning scheme. It's the living standard now. And pieces of this process are starting to make its way across the working groups. Even ECMA TC39, the committee designing JavaScript, is moving towards a more iterative process for the future. And it's a bit harder for languages because of the number of interlocking features, but it's still a sound idea. So we have this process, right? And it sounds surprisingly reasonable, perhaps. And I'd say that it's open to anyone. That's my claim. And that's the WhatWug's claim. But how does that work, right? Can you just show up on a mailing list and maybe IRC and start writing some specs? Well, largely yes, but maybe you should listen to some tips first from my dive over this last year into the standards bodies. Hard-won knowledge from the trenches, as it were. And so what follows is a series of these. And kind of the first, most obvious, is that you should lurk first. As with all new communities you're joining, whether it be a forum or a video game or whatever, you'll get better results if you lurk on IRC and the mailing list first. You'll get to know who's active in what area. You'll get to know which topics are considered important, which topics are considered controversial. You'll get to know how annoying it is to send super long messages, so you won't do that as your first message, right? And you'll even get to know basic stuff like how to write emails, like you prefer plain text and you always you put your text at the bottom, you top quote. The next big lesson, kind of an introductory one, is that solution time is later. This is from the WhatWug FAQ. You don't want to bust onto the mailing list, large spec text in hand, telling us about this amazing new API that we all really need and should definitely add to the standard because we don't know you at all, right? Instead, you want to outline the problem first. You want to get agreement among everybody that there is a problem and that it cannot be solved with existing technology and that implementers are interested in solving it. Only then is it solution time. Now, when you're crafting a solution, the important thing to do is to understand the constraints. You're working within the web platform, so any solution you create has to respect the existing platform. And this can range from its security model to the fact that APIs are always exposed through JavaScript to the idea that we don't want to introduce data races into the platform via multi-threading. A fun example of this is recently, some people have been doing great innovative work in Node.js on new types of streams. And I'm trying to bring this into the browser because I think streams are very important, as we saw, and they should be a primitive in the browser as well. So I tried to kind of nudge these people in the direction of something that would be more amenable to a browser spec. But the response I got was, well, but I don't like constructors and prototypes, so everything should just be object literals. And this was kind of a showstopper for trying to work together with these people. They weren't respecting the constraints of the platform. We're not going to give our APIs multiple personality disorder in the web platform just because you don't like constructors and prototypes. For better or for worse, the standard library, not only in the web platform but also in JavaScript itself, is based on constructors and prototypes. It's like coding style. If I'm contributing to a repository that uses comma first, even if I hate comma first, I'm not going to open my pull request with comma last just to satisfy my preferences. A practical technique for bringing these things before people, right, is to build small coalitions. This is probably the single best technique, I'd say. You want a number of people to work through the solution that you have in mind together. You want them to anticipate objections along with you, and so that you can answer them when they come up later. Ideally, your coalition should include at least one implementer who's interested in putting your solution into their browser, or at the very least an expert in the field, probably somebody who's written specs before. Then, when it's time to propose your idea to a larger group, it'll help that you're not just the lone voice crying out against apathy or against antagonism. Similarly, on the social level, you want to pick your battles. There's a lot of dumb things proposed on these lists, or things that are suboptimal, or things that have the wrong bike shed color. But you only have a limited amount of political and social capital to spend. You don't want to be seen as the excessively argumentative guy, or the guy who doesn't get it every time. People will just flip the bozo bit on you and categorize you as that person who they should never listen to. And if enough people do that, then you're in a lot of trouble. So you should save your energy for the things that really matter. The web might not get 100% perfect APIs, according to your definition of perfect. And that needs to be okay with you if you want to participate in this process. You can't introduce a constant stream of negativity when it just makes it impossible for you to later express legitimate concerns. Continuing on this kind of practical track, if a decision's been made and everybody's on board, especially all the implementers, it's pretty unlikely that you're going to come up with some super brilliant argument that dissuades them all. Instead, you'll just waste everybody's time. For an example, we've settled on IndexedDB as the database for the web. Everybody knows it sucks. Everybody knows the API is horrible. But trying to convince us that we should just throw it out and put LevelDB in the browser is a non-starter. Everybody's wasting their time trying to explain to you that they don't want to recreate another database implementation. Another example is on ES6 right now. One guy has started 2 parallel threads arguing against features which have been settled for over a year. Arrow functions and default parameters. He clearly hasn't read any of the meeting notes or any of the previous mailing list posts. Don't be that guy. A fun one, I think, is you want to leave your sense of logic at the door. And this is actually the IRC channel topic for the WhatWug. And what this really means is that things on the web platform are not necessarily what they seem. Right? APIs that seem odd, illogical, or poorly designed, they often make a lot more sense when you realize the context in which they were designed, whether it be historical, or the context of portability, or backwards compatibility, or conformance to related standards, which we may have no control over, or considerations for how browsers are implemented, which necessitate these type of things. So don't blame the standards bodies, don't blame us for DOM0, or for with in JavaScript, or for the default value versus value schism. In general, just don't blame them for the existence of sucky APIs. You can't remove them, and we have to integrate with them. And the only thing we can do is move away from them in the future when we add new features. If you want to get a standard accepted, a great thing to do is to polyfill, to speculatively polyfill for something that will probably, hopefully, be in the browser. This was a large part of the subject of my JSConf.eu talk. You want to get a working implementation of your proposal up and running, and a lot of people using it. And then it'll be very clear to the community, the standards community, that this is what developers like, this is what they want, and that it'll be a good solution that we can implement. This isn't guaranteed. The picture element has a great polyfill, but implementers have problems with that solution, so it's probably not going to be able to work. But this has worked extremely well. Things like Sizzle, the idea of selecting elements with CSS selectors was novel until this library came onto the scene, and now we have Query Selector. jQuery in general has inspired many new DOM APIs. Sass, the compile to CSS language, has inspired the CSS hierarchy idea, which will be going in soon. Promises A+ for promises, of course, but Angular, for example, for custom elements. The final tip is, if at all possible, be present. The best part of conferences for me is the ability to get to know people who you only know from the internet normally. This makes everything better. You get a sense of who these people are, and you gain sympathy with them. Arguments start evaporating, coalitions start building, understandings are reached. So people who watched the talk from last year from afar felt very offended when they were told to fuck themselves. But I thankfully was able to sit down with Michael afterwards on the after party and have a really deep, interesting conversation about what he thought was wrong with the process and why he thought these things. And we reached a great understanding, and we've been building on that ever since. So this is all really possible because we were able to meet in person and see each other as real humans. So if it's at all possible for you to make it to a TC39 meeting or a working group meetup or a conference where one of the relevant spec writers is present, or even if you're in San Francisco, just offer to buy them lunch, right? You'll get some great advantages in kind of just being able to work together. And this is two-sided, right? Like, we need to seek them out, but they should be coming to our conferences a bit more than they do, and I'm thankful for those who do. I'm investigating this, trying to get them invited more places. They're very busy people. A lot of them are just writing C++ all day, trying to get their feature actually implemented. But in the meantime, do what you can, because I think this makes a big difference. I want to close with some success stories for ways the community has infiltrated the standards process, because really the line between them is not all that clear. Ways in which these things can be applied, have been applied. And the first, of course, is promises, right? We bubbled this very much from the ground up. We had various implementers in user space. This was in like every major DOM library, every major client-side library. We standardized on it in our own community space. I talked about this at JSConf US in Promises A+. And then we took it to the DOM because they wanted to build a lot of DOM APIs on top of it. And even then, it went to ES6. It exemplifies a lot of the tactics that I was talking about, right? And each step in the process exemplifies different ones. But I'll just talk about the last one, because it's relatively recent, where we got promises into ES6, whereas previously they were planned for the DOM and for ES7. What actually happened is I took 3 days vacation. I took a bus up to Boston. I sat and listened and participated intelligently in 3 days of TC39 meetings. And on the very last day, I was given a chance to present this spec that I had written in collaboration with other people ahead of time for perusal by the committee. And somebody said, wow, this looks so good, why don't we try putting it in ES6? That's what happened. Everything went right, and it was accepted. Another more small-scale example, but one that I think is just as important, is the W3C tag, the governing architectural body for the W3C, was doing a review of the Web Audio API. And one developer, Janessa Det, who'd worked with Web Audio and presented on it several times at conferences, was able to just chime in on the mailing list, give her feedback, say, hey, we could make the APIs a lot better if we just made these small tweaks. And this was added to the tag's feedback to the working group, and I think it's going to dramatically improve the Web Audio API surface. A very simple example. One day on the web apps mailing list, a thread came up about trying to track errors written that occur in your web application. And it came up that, window on error really sucks, right? You get a message, a line number, and some other stuff. One guy, James Green, just said, why don't we add error to the end of that list? And the editor of the HTML specification said, sure, here's the change set. That's all it took, right? Part of it is because that guy had been lurking on the mailing list for a long time, participating intelligently, and was able to give a nice contribution at the right time for something he cared about. But it's a great example of how a simple developer involvement can make your life so much better, because now we can finally track our errors in the damn browser. In ES6, there's some nice built-in methods coming, and this is all really due to the work of Rick Waldron. He's been pushing very hard for these, things like array.prototype.find or object.assign and object.mixin. There's not much else to say here. This guy just put in the work. It's really good. And finally, ES6 Module Improvements. So what's interesting about these is we had this spec, iterated on kind of in isolation for a long time. And the community kept noticing, it kind of was bad, had a lot of problems. There was no ability to export a default export for your module. The syntax was reminiscent of destructuring, but it wasn't actually. So what happened is, there's a lot of noise, a lot of kind of less tactful than you would hope noise on this. And what happened is, through a few people, among them myself, Yehuda Katz, and James Burke, had to intermediate for this community outrage, kind of turn it into constructive feedback that could be fed to the people who were writing this spec, and say, oh, these are the really important features. This is the really confusing part of your current thing. We need this extra power in the pipeline. Can we do this? And that's actually what happened. So I'd say the ES6 modules are actually in a much better place now because of community involvement. And that's even despite the fact that we had to compensate for some rudeness. To wrap up, what's next? What else can we do in the browser and in the web platform in general? Well, I keep talking about this, but it's something I'm really passionate about. Getting streams into the browser, getting a good, solid stream abstraction, building on the lessons nodes learned, perhaps not duplicating that API exactly, but using it. I had a wonderful dinner and after party last night where Marcos Caceres from Mozilla, who's working on the raw sockets API, mainly for Firefox OS, he came to this conference specifically to get the feedback of developers who have been working with raw sockets, who've been working with streams. And successfully, got together with Thorsten and Substack, and we had a great discussion about what kind of things we can bring and what's important for browser streams implementation and what isn't and what we need to put together. So I was very happy with that, kind of as a first step towards putting streams in the browser. Another big focus that the standards bodies are working on today, driven mostly by implementers' needs to kind of stay relevant, is the idea of packaged apps, the idea of having apps that have special permissions but are also web apps, right? They can be put at URLs, they have URLs, they use the normal browser security model, things like that. So this is a hard problem. It's not one anybody really knows how to solve, but there's a lot of talk going back and forth between different communities, people like PhoneGap and the implementers, trying to figure out what the solution is for putting apps in your browser, because users like apps, right? Users with their Windows, their iPhones, they like apps. So we need to get those in our browser, but we want to preserve the advantages of the web. And finally, of course, there's ES7, which is just starting to peek over the horizon. ES6 is fairly finalized, but things like, one guy on the mailing list just a few days ago was like, has anybody done any work on look behind in regular expressions? Somewhat esoteric, but nice, powerful feature, and it's just kind of a missing hole. The only reason it's not done, as was emphasized, is just because nobody has put in the spec time. So if that's something that, if that kind of, tiny hole in the standard is something that you could fill, that's definitely something where everybody's interested in. Similarly, things like object.observe are still undergoing iteration, in Chrome mostly, but everybody agrees they're a good idea. It's just a matter of getting people involved, making sure it meets their use case. Async and await, that kind of nice syntax for, slight sugar on top of generators perhaps, but something that'll make your life a lot easier for writing async code. Lots of stuff coming up in ES7. You could do any of that. So, that's it. I just think that I would love to get you all involved in kind of continuing this great enterprise that we're building, this web platform, and hope to see you on the lists.